Good morning, children. Welcome back to Grade 5 Mathematics class. How are you all doing today? So I hope you're clear with all the concepts we learned in Chapter 7, Patterns and Symmetry. So we'll do the revision questions from the chapter. All of you turn to page number 125, revision station in your textbook. Let me read out the first question to you. Write the number of lines of symmetry of the following figures. So what do you mean by a line of symmetry? When you can fold or divide a shape or an object along a line into identical halves, you call that image as symmetrical, or the shape is symmetrical, and that line which divides it into identical halves is called the line of symmetry or axis of symmetry or the mirror line. Now you can see a set of 4 images here. You're asked to find out how many lines of symmetry are possible in each of these figures. Let's see the first one. See, question A. How many lines of symmetry are possible for this? There is only one line of symmetry, one vertical line of symmetry possible for this picture. So the number of lines of symmetry for this one is 1. What about the second image? How many lines can be drawn? You can draw one line like this, like this, like this, and like this. You can have a total of 4 lines of symmetry in this case. The number of lines of symmetry is 4. Now, what about image C? How many lines of symmetry can be drawn? You can draw one vertical line of symmetry and one horizontal line of symmetry. So the number of lines of symmetry is equal to 2 in this case. What about the last one? Question D. How many lines of symmetry is possible? There is only one vertical line of symmetry that can be drawn to divide this image into identical halves or mirror images. So in this case, it is 1. I hope you understand this. Now let's move on to the next question. Question number 2. Make the following figures symmetrical by drawing their reflection. When an object or shape is symmetrical about a line or through a line, or when an object or shape can be divided into mirror images along a line, we call that as reflection symmetry or line symmetry. Now here in this question, you are given one half of an image. You have to draw the other identical half so that the whole image, the full image or the completed image will look symmetrical. Let's see how we can draw the reflection of the first image so that the completed image looks symmetrical. You can draw the reflection of each of these images in your textbook itself so that the completed image looks symmetrical. Let's see how we can draw the reflection of the first one. Question A. You can draw neatly in your textbook. The first image will look like this when the reflection is drawn. The whole image will look symmetrical. Similarly, you can complete the other reflections as well. Now let's move on to the third question. Write the English letters which are symmetrical and draw their lines of symmetry. We have already learned how a few letters in the English alphabet are symmetrical. For an example, let's take the case of letter A. This letter A is symmetrical through a vertical line of symmetry. What about B? See, the letter B is symmetrical through a horizontal line of symmetry. Similarly, there are a few other letters in the English alphabet which are symmetrical. You have to find out which are those letters and you have to draw the image of these letters in your notebook. Also, draw the lines of symmetry in each case. Let's move on to the next question. Question number 4. Draw pictures of any 5 objects around you that are symmetrical. You look around and identify 5 objects that are symmetrical and you have to draw the picture of these images in your notebook. Let's see the next question. Question number 5. Write the next 2 numbers in the following sequence. Question A. You can see a number pattern there. Let's observe the pattern. The numbers are 3, 6, 10, 15 and it goes on like that. Can you identify the pattern rule for this number pattern? Let's take the difference of consecutive numbers. 3 and 6. Let's take the difference. What is the difference of 3 and 6? It is 3. And what is the difference of 6 and 10? It is 4. What's the difference of 10 and 15? It is 5. So see, the difference between the consecutive numbers form a pattern itself. So can you predict what would be the difference between 15 and the next number? It would be 6. And that number and the next number would have a difference 7. And it will go on like that. So what comes next to 15? It would be 15 plus 6. And what is it? It is 21. See, the difference between 15 and 21 is 6. And the next number would be 21 plus 7, which would be 28. So that the difference between 21 and 28 is 7. So here it is 3 plus 3, 6 plus 4, 10 plus 5, 15 plus 6, 21 plus 7. And it will go on like that. Let's observe the next pattern. The numbers are 7, 17, 27, 37 and goes on like that. Take the difference between the numbers 7 and 17. 7 plus 10 is 17. 17 and 27. 17 plus 10 is 27. Again, 27 plus 10 is 37. So what would be the next number? It would be 37 plus 10, which is equal to 47. And what is the next number? It would be 47 plus 10, which is 57. And it will go on like that. Now let's observe the third question. Observe the numbers 2, 5, 10, 17, and it goes on like that. And can you identify the pattern rule or the logic for this number pattern? See, what is the relationship between 2 and 5? 2 plus 3 is equal to 5. And 5 and 10. 5 plus 5 is equal to 10. Then 10 and 17. 10 plus 7 is equal to 17. So the next number would be, see the difference between the numbers form a pattern. 3 plus 2, 5, 5 plus 2, 7, and the next would be 7 plus 2, 9, then 9 plus 2, 11, 11 plus 2, 13, and it will go on like that. So this is the pattern with the difference of the numbers in the given question. Question C. 2 plus 3, 5, 5 plus 5, 10, 10 plus 7, 17. So the next number would be 17 plus 9, which would be equal to 26. And the next number would be 26 plus 11, which is equal to 37. The next number would be 37 plus 13. And the pattern will go on like that. Let's move on to the next question. Question D. The numbers are 2, 5, 10, 50, and it goes on. Observe the pattern. Can you identify the pattern rule for this number pattern? See, the numbers 2, 5 and 10. 2 5s are 10, or 2 into 5 is equal to 10. 2 into 5 is equal to this 10. And again, this 5 into 10 gives the next number 50. Then what would come next? It would be this 10 into this 50, which is equal to 500. And what would be the next number? It would be this 50 into this 500. And what is 50 into 500? It is equal to 5 5s are 25, and then you have to put 3 zeros to the right of it, and you get the number 25,000. And can you predict what would be the next number in this series or in this number pattern? It would be this 500 into this 25,000. And it will go on like that. So I hope you are clear with all these number patterns. You can work out more examples. Let's move on to the next question, question number 6. Find the 23rd triangular number. What do you mean by a triangular number? See, when a number can be represented with dots, and the dots can be arranged in the form of a triangle, we call that number as a triangular number. And here you can see a few triangular numbers. 1, 3, 6, 10, 15, and it will go on like that. And see how these numbers are represented using dots and how the dots can be arranged in the shape of triangles. If you observe the numbers in this pattern, 1, 3, 6, 10, 15, etc. You see the first number is 1, which is the first counting number. The second number is 3, which is the sum of the first two counting numbers. So the second number in the series is the sum of the first two counting numbers, which means it is equal to 1 plus 2, that is 3. Now the third number is the sum of the first three counting numbers, which is 1 plus 2 plus 3, which is equal to 6. And the fourth number in the triangular number series is the sum of the first four counting numbers, 1 plus 2 plus 3 plus 4, and that is equal to 10. The fifth number is the sum of the first five counting numbers. So can you say what would be the 15th triangular number? It would be the sum of the first 15 counting numbers. What would be the 29th triangular number? It would be the sum of the first 29 counting numbers. So that is the pattern when you have a triangular number series. So if that is the case, can you say what is the 23rd triangular number? It would be the sum of the first 23 counting numbers. And the sum of the first 23 counting numbers is equal to 1 plus 2 plus 3 plus goes on like that till where? Till 23. And that is equal to 276. So the 23rd triangular number is equal to 276. Clear? Now the next question. Question 7. Find the 56th square number. So what do you mean by a square number? See, when you have numbers which you can arrange into squares, those numbers are called square numbers. And you can obtain a square number by multiplying a given number by itself. So the square of a given number is the number multiplied by the number itself. For example, the square of 1 is 1 itself. 1 into 1 equal to 1. The square of 2 is 4, which is 2 into 2. Square of 3 is equal to 9, which means 3 into 3, and that is equal to 9. And you can see a pattern here with the square numbers of the first four counting numbers. Square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, and goes on like that. So numbers which are obtained by multiplying each number to itself are called square numbers. So can you say what would be the 56th square number? It would be 56 into 56 itself, and that is equal to 3136. Clear? Now, the 8th question. Find the pattern in the following block of a calendar. So we have learned we can identify different number patterns in a calendar. You see here there is a block of numbers taken from a calendar, and you have to identify the pattern in this block. Can you identify the pattern? See the numbers. The number 4 and the diagonally opposite number 20. The sum of 4 and 20 is 24, and in the middle we have the number 12, which is half of 24. Now the next number 11 and the opposite number is 13. 11 plus 13 is also 24. In the middle you have 12, which is the half of 24. And the next number 18 and the diagonally opposite number is 6. 18 plus 6 is also 24. 12, the half of 24. 12 is in the middle. Now the next number 19. 19 and the opposite number is 5. 19 plus 5 is also 24. And in the middle you have 12, which is the half of 24. So we can see a pattern there. You can observe different patterns in the numbers written on a calendar. Now let's move on to the next question. Complete the patterns. We have 2 patterns given there, and space is also provided in the textbook. The first pattern, can you say what comes in the pattern? The first one, it will look like this, and then it goes up and there you have squares. And it continues like that. And you can complete the pattern in the space provided. The next one, the letter E, it is turned, then again it is turned, again turned, turned, then the next one would look like this, and it goes on like that. You can complete the pattern in the textbook itself. The next one, question number 10, draw a tiling pattern and a border strip of your choice using geometrical shapes. So you have learned about tiling and tessellations in your lower classes. When you arrange polygons in such a way that there are no gaps or overlaps in between, we call that as a tiling or tessellation. And you can create a beautiful tiling of your own using different geometrical shapes. You can draw the tiling in your notebook itself. Now, we've come to the end of the revision station page. In the next page, you can see the worksheet. A worksheet is given there in 126. You have to go through all the topics that we learned in this chapter once again, and then you have to work out the worksheet given there. So once you're done with it, you can take a picture and send us through Teams. So children, we have come to the end of chapter 7, Patterns and Symmetry. We'll meet in the next class with a new chapter. Till then, bye.